which is acidic and alkaline level, dissolved oxygen DO, and total suspended sodium TSS. Okay, so these are the parameters that you are required to determine the concentration of all these parameters. So from this concentration, kita boleh determine what is the quality index of this river. So this is the formula to calculate the water quality index. 0.22 multiply with the sub index of DO. Okay, SI ni, SIDO ni, SI represent the sub index. So DO represent the dissolved oxygen. Okay, so 0.19 sub index of BOD, 0.16 multiply with the sub index of COD, and so on. Okay, so this we call as the WQI formula, and we will use this formula to calculate for the sub index. So now how do you calculate the sub index? So this is the formula given for each parameter. Okay, kita ada 6 parameter, so setiap parameter ni kita kena kira lah, DO, BOD, COD, and so on. Okay, so it also depends on the concentration. So for DO kita ada few formula here, whether it is 0, 100, or we can use this formula to determine the SIDO. So it depends pada your punya concentration. For example here, BOD, if the, zoom in first. Okay, if the concentration of BOD is less or equal to 5, we use this formula. If it's more than 5 mg per liter, we use this formula. Okay, so same for COD. If the concentration is equal or less than 20 mg per liter, we use this formula. If it's larger than 20, we use this formula. Okay, so this is the formula that you have to know so that you can calculate the WQI. And then once you obtain all the sub-index value, key in this formula, you will get the WQI value. Okay, so on this WQI, you tengok dia punya range dia, whether it is what is the range there. Okay, so it is clean if the WQI is between 81 to 100, slightly polluted 60 to 80, polluted is 0 until 59. Okay, so this is the range of the index. So in order for you to classify the class pula, sama ada kelas 1 ataupun kelas 5, you boleh tengok dia punya value dekat table sini. Okay, so it is bigger than 92.7, this is class 1. Maksudnya river ni memang sangat bersih lah. So class 2 between 75.6 until 92.7. Okay, and so on. Class 3, 4, and 5. Okay, so now how do you calculate this? Okay, okay, so before that, ini tak ada apa-apa ini this one is not that important. Okay, okay, the second one is the INWQS. Okay, so INWQS defined as the C class. You boleh define 6 classes of river, whether it is class 1, class 2A, class 2B, class 3, class 4, and class 5. So the difference is that for WQI, the class 2 only, dia tak ada class 2A, 2B. So 1, 2, 3, 4, 5. That is WQI. But for INWQS, dia ada class 1, class 2A, class 2B, class 3, class 4, and class 5. So class 5 being the best and class 5 being the worst. So INWQS serves as a good benchmarking tool for the beneficiaries users stipulate therein. Hence, it also can form a basis for the target water quality in river rehabilitation efforts. So we can use this to as a benchmarking, as a tools to determine whether the quality of the river is good or not. And if it's not good, we can establish, we can actually estimate the scale of the rehabilitation required for the river. Kalau dia punya paling worst ni, class 5, so means that the scale for the rehabilitation memang sangat besar. So whether it's good economical or not, it depends on the designer. Okay. So this is the table of the INWQS. So different from the WQI. Okay. INWQS ni dia tak ada formula apa-apa, dia tak perlu kira apa-apa, you just comparekan data dia saja. Okay. So it is class 1, it's good for the conservation of natural environment. Practically no treatment necessary, so tak perlu treatment pun tak apa kalau dia class 1, except kita boleh buat disinfection ataupun boiling only. Okay. It is good for the fishery 1, fishery level 1 ni very sensitive aquatic species. So in order for you to conserve this animal, very sensitive aquatic species, you have to make sure that that level is in class 1. So class 2A is a conventional treatment required, and also good for the sensitive aquatic species. So class 2B recreational with use with body contact. So yang ni contoh kalau air terjun, air boleh mandi kat sini, kawasan ni. Of course lah, kelas 1, kelas 2A pun you boleh mandi, tapi it is much more useful for other critical activities. Okay. So class 3 require extensive treatment. So means that extensive treatment ni dia perlukan advanced treatment. Okay. And it is good for the common economic value and tolerant species, livestock, drinking dan sebagainya. Okay. So that is for the class 3. Class 4 only for the irrigation, tak sesuai untuk activities in class 3. Dan class 5 is the worst, yang mana kita memang tak boleh guna langsung air ni untuk all these activities. Instead kita kena buat rehabilitation process so that it can achieve other classes rather than 5. So you want to make sure that kita comply dengan class ni based on the data yang kita dapat daripada river. Okay, now this is the example. Should be our last example here. We only have one example. Okay, this is the data obtained from the Sungai Way. We have 3 points, W1, W2 dan W3. This is the point of location that we take the water sample and we do the testing. So 3 points of testing, W1, W2 and W3. I will show you the example for W1. So W2 and W3 nanti you cuba buat sendiri, you kira. So now for W1, you tengok first kita nak kira the WQI. You want to use the WQI. Okay, so this is the example. I already calculated for you. Okay, how to calculate the WQI for this data. So the first one here is the DO saturation is equal to 41.88%. We obtain from the nomogram. So kat mana kita dapat ni 41.88%? The nomogram normally kalau soalan ni keluar dalam test akan berilah. So this is called as a nomogram. Okay. So this nomogram can be used to determine the saturation percent in your oxygen, in your water. Okay, from the oxygen. Okay. So kalau as you can see from here. Okay, so the formula for WQI, okay, for the sub-index for DO, SIDO, must be in the percent of saturation. Dia bukan dalam bentuk the concentration of the oxygen, but in the percentage of saturation, oxygen saturation. So in order for you to obtain this unit, you kena guna nomogram. Okay. So by first, how do you use this? First, you have to determine the water temperature, the temperature of the water for the water sample. But in this example, dia tak beri water temperature dia. So you just assume the normal temperature for the water at the open space river is around 25 degrees Celsius. So you ambil 25, okay, and then you prolongkan dia and then match it with the oxygen. The concentration of the oxygen based on you punya data. So di sini the DO is 3.49 mg per liter. Okay, so oxygen ppm sama juga dengan milligram per liter they are the same unit. So you just from the temperature tadi you just match it, buat straight line and then match until the concentration of the DO, which is almost 3.5. Okay, so now the saturation of the oxygen from this middle line here. Okay, so middle line here you baca kat sini, so it is around 41. It should be around 41. Okay, so this is 41%. So once you obtain the 41%, okay, you just after that you tengok dia punya range dia kat sini. So this X ni merupakan kita punya percentage saturation. If it is less or equal to 8, SiDO is 0. Okay, so kita tak boleh guna formula ni lah. Okay, so because kita punya saturation tadi adalah 41. If it is bigger, equal or bigger than 92, the SiDO is considered as 100. This is not our range here. And then our range is lie between 8 and 92. Okay? So we do this range. So you have to use this formula, SiDO, the third formula here. And then we just key in the 41.88 into the X value, and you will get the sub-index for the DO, which is 37.53. It is unitless because this is the index, the sub-index of the unit. Okay, so that is for the SiDO. And the second one is the sub-index for the BOD, SiBOD. So what is the value of BOD for the W1? It's a 5 mg per liter. Okay, so 5 mg per liter, kita tengok formula SiBOD. If it is bigger than 5, you use this formula. If it is equal or less than 5, you use this formula. Okay, so means that the first formula is valid for our data, because it is equal or less. Okay, so we use 104 minus 4.23x. Okay, so with this formula, the x will be the concentration of BOD. You will get 79.25 sub-index. And COD, okay, COD, what is the range of our COD here? COD is 28. Okay, so 28 lies between the second range here, x bigger than 20. So we use the formula here, the second formula. Okay, so 103 exponential to the power of negative 0.0157 multiplied with x, where x is the concentration of COD. Okay, minus with 0.04x, you will get this formula. And how about the ammonia? AN. Okay, so AN is equal to NH3 negative N. Okay, this is ammonia here. Okay, so ammonia is 6.34. Look at for the ammonia. Okay, and if it's bigger than 4, you can see that here. If it's bigger or equal than 4, SiAN is 0. Okay, so means that the sub-index for this particular component, the ammonia, is equal to 0. Because kita 6.34 lah, lebih besar daripada 4, so become 0. And suspended solid, okay, the suspended solid is this one, TSS, total suspended solid, is 12 mg per liter. Okay, so 12 mg per liter, look at the formula here. So it is in between 100 to 1000 mg per liter. We use this formula, the second one. So the second one here is the formula. Okay, so replace the x value with 12, the concentration of TSS, you will get 90.5. Okay, and finally the pH is equal to 7.10. Okay, so look at this range here, 7.1, kat mana berlaku? So it is at the third part here, the third formula here. Negative 181 plus 82.4x minus 6.05x squared, where x ni adalah merupakan nilai pH. So we use this, the third formula. Okay, and include it, calculate all the, okay, calculate the sub-index for the pH based on the formula given, and you will get 99.06. So once you obtain all this data, you can key in the formula here, okay, ataupun dalam nota kita ni, key in the formula this one, include all the SI yang you kira previously, and you will get the WQI. So in this case, for the sample 1, the WQI is 60.12. So look at our table back. 60.12 lies dekat kelas mana? Okay, it is in class 3. Okay, so that is the class for our river. But that one is for the sample 1. So kita ada dua lagi sampel. Okay, so you have to consider lah untuk sample 2 and sample 3 apa dia guna kelas by using WQI. So now that is the method for the WQI. How about INWQS? So INWQS, you have to use the which table? This table here. Okay, so this is for the INWQS. But this one you don't have you don't have to do any calculation. Okay, but it is much more subjective. INWQS dia much more subjective sebab dia perlukan decision yang betul. I will show you why. Okay, so this is the data from the point 1 water sample for the point 1. So the first one kita ada pH 7.1. So you tengok pH 7.1 ni dia ada dekat kelas mana-mana pun dia ada. Yeah? So the range for 7.1 ni berada kelas 1 until dengan kelas 4 dia ada ya. Okay. So you can choose any class 1, but normally pH kita akan skip dulu. Kita akan kita IV for a while. Kita akan start dengan DO dan ada parameters dulu lah. Okay, so DO berapa? 3.46. So 3.46 for DO, where is the range of that DO? So it is in class 3, between 3 to 5. So DO in the class 3. Total suspended solid 12 mg per liter. Where is the total suspended solid? This one, total suspended solid 12. So it is in class 1. Class 1 maknanya untuk term of total suspended solid dia agak baik lah. Memang baik lah sebab class 1 ni menunjukkan dia it is clean from the total suspended solid. Okay, class DO ni it is so-so je lah. 3.46 class 3. Okay. Ammonia 6.34. So mana ammonia? Okay, it's ammonical nitrogen, top sekali, paling tinggi. Dan dia tengok kelas 5 So that means that this ammonia, the concentration of ammonia is very high for this river. So kelas 5 menunjukkan memang is the worst case for the ammonia. And BOD berapa kat sini? BOD adalah 5 ya. So dekat mana 5? Kelas 1 dia hanyalah 1 dan less 1 or less than 1. 3 kelas 2B pun 3 juga. Kelas 3 so it should be class 3. So ni salah, patutnya it should be class 3. Okay, so because it is 6 so 5 ni termasuk dalam lingkungan 6 lah, the range. So kalau you nak tahu dia kalau less wait a second, oh sorry, betul lah this one is class 2B so it's lah. Okay, class 2B. Okay, because 6 is 6 or between 6 to 12. Okay, dia between lies in the class 3. Kalau dia 12 yang ke atas, yang 12 dia akan kelas 4, lebih tinggi daripada 12 adalah kelas 5. Okay, for this case it is 5 5, so means that it is class 2B between 3. Okay, daripada 3 tapi dia tak melebihi 6. Okay, so means that is the lies between the class 2B. Okay, COD 28. So 28 should be, this is 25. Okay, COD should be class 2B. Okay, class 2B 25. This is 50 and above. Tapi 48 lies between this one 25. Okay, you will limit 2A is up. You can limit 2A, tapi 2B is much more reasonable lah. Okay, 2 plus 2B. And fecal coliform, this fecal coliform ni merupakan the colony of bacteria from the fecal, from the najis haiwan dan najis manusia. That's what we call as a fecal. The fecal coliform 10,000. So 10,000 dekat mana? Kita tengok di sini. So fecal coliform lies between class 3 and class 4. So in between 5,000 to 20,000. This is the range, 5,000 to 20,000. So we can take class 4. Maybe 3 or 4 is up to you. In this case I choose 4. Okay, so kat sini you ada banyak selection yang you pilih-pilih. All this one we consider as a very subjective. Dan kenapa saya ambil normally kalau you ada pilihan antara 2A dan 2B, saya ambil 2B because due to the presence of the high concentration of nitrogen, ammoniacal nitrogen ni. So normally ni ammoniacal nitrogen is very dangerous. It's very hazardous to the aquatic species dalam air, dan bila consume dia akan membahayakan kesihatan, especially pada babies dan sebagainya, dan di mana dia akan reduce dia punya capability human darah untuk bawa oksigen sampai ke otak. So dia boleh suffocate, dia boleh buat suffocation, especially pada babies ni. Okay, so this is quite dangerous due to the high concentration of ammonia. So that's why if you have a selection between 2A and 2B, you have to choose the class which is much more worse. So in this case, kalau you have 2A and 2B, I choose 2B. Kalau you are between 3 and 4, I choose 4. Okay, so it's up. Kalau 5 ni memang dah critical sangat lah. Okay, so ammonia ni memang paling critical. Okay, so pH ni you can choose any class you want lah. So appropriately kita boleh ambil kelas 4 boleh, 3 ataupun 2B ataupun 2A. So it's up to you. pH is not that critical in this part, because it is quite neutral. 7.1 ni dikira sebagai neutral. It's not that critical, but the most critical is ammonia. And this ammonia ni akan effect juga pada concentration of BOD and COD. So that's why we want to make sure that the parameter yang kita analyse ni mesti dia kena tahulah dia punya hazard level tu, dia punya effect level pada human. So that's why this one is very subjective. The designer normally ataupun the researchers classify this river based on their expertise, based on their experience, by using this INWQS. Dan there is some issues. Sebenarnya WQI ni, Water Quality Index yang kita buat calculation tadi, it is not as accurate as the INWQS, because WQI dia consider hanyalah 6 parameter saja. But kalau you tengok NWQS, actually NWQS akan consider a lot of parameter. Nampak ni ada bermacam-macam parameter. Tapi kalau WQI ni adalah consider 6 parameter saja. So that's why ada certain issues sekarang ni yang di mana kita the result from the WQI is not that reliable, tak reliable sangat compared to the INWQS. So, but INWQS requires you for you to have a good judgement skill. Very subjective. Okay. Alright class, so itu I think itu saja untuk bahagian chapter 7. Alright. So the rest for level 2 and level 3 nanti you boleh cuba buat dan dapatkan result dia, ya. Kalau sebarang soalan boleh tanya saya dalam WhatsApp. Okay, thank you so much class, and see you later.